Okay. Yeah, hope, I guess you can hear me. Yeah, I guess you can hear me and check my screen, right? Okay, now welcome to the third session of Geomatics Engineering Gate class. We have previously discussed about linear measurements, angular measurements, and what are the errors in it, errors and rectifications. And we have gone for the leveling, right? We have used, we have previously, in the previous class, we have discussed what is leveling, why do we level, uses, objectives, and what are the types of levelings, right? So let's uh, let's quickly go through few terms in leveling. Okay, so station. What is station? Station is nothing but location of leveling staff. Location of leveling staff is nothing but station. Next, height of the instrument. Height of the instrument is the reduced level. It is called the reduced level. What is backside? It is the site taken on a point of known elevation. It is also called as plus site. Plus site. Okay, because height of the instrument can be calculated by adding backside to the known ORL. So if I want to calculate the height of instrument, height of instrument, then I will add RL, reduced level, plus backside. So that's why it is also called as plus site. Next, foresight. It is the site taken on a point of unknown elevation. It is the site taken, here you can see in the example, it is the site taken on the point of unknown elevation. Okay. It is also called as minus site because RL of any given point, RL of that point can be calculated by deducting the foresight from height of instrument. Okay. So RL of any point can be calculated by subtracting the foresight from the height of instrument, Hi minus Fs. So you can see reduced level, we can calculate reduced level is equal to difference of height of instrument minus foresight. Next is intermediate site. What it is the site between foresight and backside. Site between foresight and backside. Okay. Intermediate site is the site between foresight and backside. So you can take RL of any point, when intermediate site is given is equal to height of instrument minus intermediate site, IS, Hi minus IS. Line of sight. It is an imaginary line passing through the optical centers of objects and intersection of cross sights. So next, methods of reduction of levels. So what are the methods of reduction of levels? There are two methods. HI method or collimation method. HI method or collimation method, rise and fall method. Got it? These are the two methods of reduction of loads, reduction of levels. So HI method, it is not suitable for intermediate sites because there is no check for it. Got it? HI method, it is not suitable for intermediate sites. So let's take one example. So there was given 2 points A, B, and C, and the reduced level is 2000. Okay, the instrument is set up there. You can see the 3 stations A, B, C. What is the backside of A? At A, A is the starting point, right? So there won't be any backside. Next, what is the intermediate side? You can see 1.1. What is its reduced HI? How do we calculate HI here? RL plus BS. Okay. So here HI is RL plus BS. And RL at any point is nothing but HI minus FS. Okay. So next, at A point, what are the points we have? At A, it is an intermediate point, 1.1 we have noted. And C, elevation of C is 3.6. So it is a foresight. We have noted it in the foresight. Now we have calculated the HI and RL of all the points. Next, we will calculate summate sigma BS backside minus sigma FS is equal to last RL minus first RL. Last RL minus first RL. Last reduced level minus first reduced level. If you can see it, it is 0.6. Okay, this is the check. Next we comes to rise and fall method. You can see. So same readings I have written, same readings for the same condition, rise and fall method. How do you say what is rise and what is fall? You can say if succeeding reading is less than preceding reading, then it is called rise. If succeeding reading is less than preceding reading, then it is called rise. So here you can see it, rise. If succeeding reading is greater than preceding reading, then it is called fall. If succeeding reading is greater than preceding reading, then it is called fall. So that is rise and fall. You can see here my succeeding reading is less than preceding reading. Hence it is a rise. So I have written that in rise. If my succeeding reading is less than preceding, if my succeeding reading is greater than preceding reading, then it is fall. I have written in the fall. Okay. So what is the check? Check is sigma BS minus sigma FS, backside minus foresight is equal to sigma rise minus sigma fall. Okay, that is equal to, we have to check it. If it is 0.6, yes. So the reduced level is 0.6. So these are the two methods. HI, height of the instrument method or collimation method, rise and fall method. You need to remember you need to note the points, foresight and backside, and you need to remember what is rise and what is fall in rise and fall method. And in height of instrument method, the height of instrument HI is equal to RL plus BS. And the reduced level is equal to HI minus FS. Okay. So you need to remember all these things. These may be asked in the questions, the bits of it. The concepts are very important here. So the rise and fall method is superior than height of instrument method, as we can verify it. Okay, rise and fall method is superior than HI method, as it can be verified. Rise and fall method is used for small areas Rise and fall method, it is generally used for small areas. Preparation of contour maps. Preparation of contour maps. LS and CS, longitudinal section and cross section. This method is generally used for that. Okay. The next method is inverted staff method. You can see it here. Inverted staff method. Inverted staff method. So the difference in height of roof, this is called roof. The upper position is called roof, and the lower position is called pitch. Okay. So we locate the instrument at the middle, and if we look back, that is back side. If we look front or unknown elevation is front side. Okay. So difference in the height of roof and pitch is BS plus FS, right? You can see it. Difference in the height of roof and pitch. So what is the reduced length of pitch? RL of is equal to RL of roof minus BS minus FS. Got it? So reduced length of plinth is equal to RL of roof minus BS minus FS. Next, you can see it. If a point, if a few level points are given, they ask you to identify what is FS and what is BS. Can you do it? Yes. If there is improving in the level, then we can take it as FS. Here you can see 2.2, 2.4. These levels are four sides and back sides. Instrument is shifted after third and fifth reading. You can identify it, right? So this is my FS first, and third, in third one instrument is placed. After that, if I next intermediate site is 0.9, and if I go with this in fifth reading 2.4, and if the back side, you can identify it if you given the different levels. When is the instrument is shifted at which reading, and which readings are four sides and back sides, you need to identify them. Next, leveling on slopes, falling gradient and rising gradient. Okay, so how can you say it is a falling gradient and rising gradient? Okay, if the slope is falling, then it is falling gradient. If the gradient is rising or slope is rising, then it is raising gradient. Okay, so falling gradient means the initial backside 0.7, you can see it, and the second backside is 1.2. So these are falling gradients and rising gradients. Next, balancing backside and foresight. When it is required to evaluate the RL, reduced level, difference between any 2 points, taking BS on point 1, and FS on point 2, it is necessary to make the distance equal from the instrument to each of the stations to eliminate the error due to line of collimination and its adjustment. Okay, error due to curvature and refraction. When so to eliminate error due to line of collimination and its adjustments, error due to curvature and refraction. The instrument is generally placed in the middle, equal distances. Okay. So what are these corrections? What are the corrected if what are the corrections? Corrected staff reading, corrected staff reading at 1. So what is it? It is x1 y1, right? So x1 minus y1 will gives you the corrected reading of staff at 1. So corrected reading of staff at 2 is equal to, here you can see x2 y2. So x2 minus y2. So what is the true difference? True difference in levels between 1 and 2. Between point 1 and 2 is x1 minus y1 minus x2 minus y2. That is equal to x1 minus x2. Right? So if y1 is equal to y2, if y1 is equal to y2, then it is x1 minus x2, right? If y1 equal to y2, then it is x1 minus x2. And next, uh, if y1 equal to y2, then d1 tan alpha is equal to d2 tan alpha. Agree? So these are the angles d1, d2. Then if y1 equal to y2, d1 tan alpha equal to d2 tan alpha. Then d1 equal to d2. The instrument is centrally located. Okay. So this is the thing. How do we balance the backs? If this is to balance the backside and foresight, and to eliminate the errors, we need to place the station location point at the center, right? Next, correction for curvature. Okay, so it is the difference between the horizontal line and the level line. You can see it. This is the horizontal line, level line. The CR, coefficient of curvature. See, coefficient of refraction. The CR is called the coefficient of refraction. CC is called the coefficient of curvature. So it is the difference between horizontal level and the level line. Horizontal line and the level line. Okay. The apparent reading is more than the object appears lowerly, right? So object, the reading will be lower than it is. The reading is more, and the object appears to be lower. Object appears to be lower than reality. Reading is more and the object appears to be lower than reality. You can see it, right? So hence the correction for curvature is negative. Hence the correction for curvature is negative. So how do we calculate? CC is equal to d square by 2r. So d is the distance, r is the radius of curvature. So if it is generally for radius of curvature of earth surface is taken as 6370 kilometers. You know it, right? If it is not given in the question, then you need to take this value. This is always negative. CC, correction for curvature, is d square by 2r. So if we consider this r as 6370, and if I substitute it, then my value is CC is minus 0.07857 d square. Got it? Cc is minus 0.07857 d square. Cc is in meters and this d is in kilometers. For this formula, Cc is in meters and d is in kilometers. Got it? So this is about correction for curvature. Next, correction for refraction. So the line of sight is deviated from the horizontal line. Hence, the effect of refraction is to make the object appear higher than it is real. So loss of sight and is different, right, from the level surface. Then, due to refraction, object will appear higher than in reality. CR is always positive. Okay. So how do we calculate the coefficient of refraction CR? It is calculated using this formula. It is equal to 1/7 of Cc. If we substitute what Cc here, then it is d square by 14r. And if we substitute r value, radius of earth value, then CR will be 0.01122 d square. D is in kilometers, CR is in meters. Okay, got my point. Next, another thing is we have seen CR, coefficient of refraction, correction for refraction. Next, correction for curvature, and we have that one combined correction. Combined correction is equal to Cc plus Cr. Okay, so taking these two values, minus 0.07857 d square plus 0.01122 d square. If we summate, this whole value will be minus 0.06735 d square. You need to remember this. Okay, this is combined correction C. So let me summate these values. Cc is equal to minus 0.07857 d square. Cr is equal to 0.01122 d square. Combined correction C is equal to minus 0.06735 d square. Got it? Next, distance of visible origin. Next point is distance of visible origin. So we generally we don't consider the curvature of Earth. If I see like this, I felt like it will be like plane surface and a rectangular. Plane perpendicular surface, and I will take this formula. But there will be a curvature. So same hypothetical hypotenuse elements like that morning we have discussed, na? So that height, correction height, distance due to visible origin. This height, vertical height h is equal to combined correction 0.06735 d square, and d is equal to root of h by 0.06735, right? H is in meters. So this is the correction for visible origin, distance of visible origin. Next point is profile leveling. So what is profile leveling? It is used to locate the central line of the path. The central line of the path may be curved or may be straight. It is generally used to calculate LS and CS, longitudinal sections and cross sections of the areas. So generally for calculation of volumes, areas, excavations, areas, volumes of excavations, of excavated surface can be calculated using profile leveling, cutting and fillings, excavations and all. Next, reciprocal leveling. What is reciprocal leveling? When it is necessary to carry the leveling across a river or any obstacle between 2 points are situated, then we go for the reciprocal leveling. Okay, the level we can't easily find out the FS and BS because they are interrupted, right? So this is we will take this method, reciprocal leveling, for the approximately equal values. Okay, this method is necessary opted to obtain the accuracy and to eliminate the errors. If there is any leveling, if leveling has to be carried with any obstacles, with intermediate obstacles. Okay, so to eliminate the errors, we will consider this method. What are the errors? What are the errors which we can eliminate using this reciprocal leveling? One, error in line of collimation, error in line of collimation, error due to curvature, and error due to refraction. Refraction is partly eliminated. Error due to refraction, it can be partly eliminated. So here you can see one instrument setup is from A to B and the second instrument setup is from B to A. Okay, second setup is at B. We will approximately look from here to here and after here to here. So the true difference, so in case if A is A, then HA, B to A, then it is HA dash, right? A to B, then it is HB, B to B, then HB dash. So one, the true difference in levels between A and B, true difference between A and B, this H is equal to half of HA minus HB plus HA dash minus HB dash. So this is the average of the difference of apparent readings from both sides. Next, what is reduced level of B? It is nothing but reduced level of A plus or minus H. Okay, difference of levels. Next, what is total error? as you all know, errors are summation of collimination, error due to curvature, and error due to refraction. Total error E is equal to minus 1 by 2 of HA minus HB minus HA dash minus HB dash. So E, total error E is equal to error due to collimination plus error due to curvature plus error due to refraction. So we have previously discussed what are these errors and what are their values also, right? If my instrument setup is like this, and this is alpha, and this is, what is this error? Error due to collimination, because there is change in the level line, right? So this reduced level is for suppose 100, and here RL is 11.60, and the distance is D. Then what is tan alpha? E collimination by D. Okay, sometimes you won't get alpha, they will ask you to calculate alpha. Then this is the method. Sometimes they will give you E collimination and the distance. Next is the sensitivity of bubble tube. So as you have seen, one bubble tube is present in the instrument. So why do we need bubble tube? To uh, to fix the horizontal axis, right? And to eliminate the errors. So if we want to fix the thing horizontally with the help of level tube, bubble tube, we will do that, right? It is an angular value of one division marked on the level tube. It is an amount that horizontal axis to be tilted so that the bubble will move from one graduation to another graduation. That is called sensitivity. Fine. So it is nothing but the graduation, angular value of one division marked on the level tube. So what is N? N is nothing but number of divisions. Divisions. Let us consider N as number of divisions. S as difference in staff reading. Difference in staff reading before and after disturbing the level. Before and after disturbing the level. So generally S is equal to CF minus CE. You can see it. S is equal to CF minus CE. In the triangle FAE, what is tan alpha? Tan alpha is equal to S by D, right? D alpha is equal to, we can consider tan alpha as alpha is equal to S by D. Okay. In arc of AOB, NL is equal to RL. You can see NL is equal to R into alpha. NL is equal to R into alpha, length of the arc formula. So what is alpha here? NL divided by R. Next, the radius of curvature of level tube. What is the radius of curvature of level tube? Radius Radius of curvature of level tube. R is equal to NLD by S. Alpha dash is equal to L by R, radians. If I want to convert it, it is in radians. If I want to convert it in seconds, it is 206265 L by R in seconds. Okay. So the sensitivity of the tube, bubble tube alpha is equal to 1 by R, that is equal to 206265 S by ND. This is the sensitivity of bubble tube. What are its units? The units are units for sensitivity. This is an important 1 mark question. They will ask you. The units are seconds per what is the single division in the tube. Single division will be 2 mm, right? So I will write it neatly. The units are seconds per 2 mm. Okay. So sensitivity depends upon what factors? Sensitivity depends upon increasing the radius of level tube, increasing the diameter of the tube, increasing the length of the tube, decreasing the roughness of the wall, decreasing the viscosity of liquid in that level tube. Okay. Sensitivity depends on increasing the radius, diameter and length of level tube and decreasing the roughness and viscosity of the material used in the bulb. Okay. So till that we have covered the traversing theodolite, sorry, leveling part. I'm very sorry. Next, we go for the previous gate problems. We'll solve previous gate problems. So here the question is given, fly leveling is carried out from a point having an RL 560.5 to the point 2. If my BS and backside is 6.45 and FS is 8.565, what is the RL of point 2? They are asking us to calculate the RL of point 2. So what is the, how do we check in leveling? So sigma BS backside minus sigma foresight is equal to last RL minus first RL, right? So what is the BS here? 6.475 minus what is the FS here? 8.565, right? Is equal to, he has given FS and BS and first RL. RL is, first RL he has given. We need to calculate RL too. First RL is 560.5, right? So RL of second point is nothing but, after simplification, the value is 558.41 meters. Got it? So this is one previously asked question, 558.41 meters. This is the value. So next question, it is asked, the following observations were taken in reciprocal leveling. The distance between A and B is 1 kilometer. Okay, distance AB is 1 kilometer. The instrument, the staff readings they has given. So they are asking us to calculate the collimation error. Okay. So reciprocal leveling, we know how do we calculate error in reciprocal leveling? The distance given is 1 kilometer, right? Distance of AB is equal to 1 kilometer. So how do we calculate error in reciprocal leveling? Error is equal to minus 1 by 2 into HA minus HB minus HA dash minus HB dash, right? So that is equal to minus 1 by 2 into what is HA? 1.625 minus 2.545 minus 0.725 minus 1.405, right? So what is this value? Point plus 0.12. So they are asking us the uh, collimination error due to collimination, right? But this error we got is nothing but the whole error, true error. It's a combination, right? So what is E? E is equal to E collimination plus error due to curvature plus error due to refraction. So this the total value ER. It is given point. We calculated it's 0.12. We need E collimation plus E curvature. So how do we calculate E curvature? E due to curvature is nothing but value 0.07857 into D square. Distance is in kilometers, right? And it is luckily in problem, it is given in kilometers only. So my EC value is 0.07857. Next, ER value. What is ER value? It is minus 0.01122 into D square, right? So here we got E value and EC value, EC and ER value. So EC 0.07857 minus 0.01122. After substituting and calculating, we got error due to collimination as 0.0527. Got it? So these are the errors due to collimination. So these are two previous gate problems we have dealt. Mostly this method or this model they will ask. So what is the final answer? 0.0527, and it's a plus value, right? This is your collimination error. So till now we dealt with leveling. Next, let's go with the traversing and theodolitic traversing. Okay. Can you see my screen? There's a lag. Yes. Sorry, there is a lag due to internet connectivity. Yeah. We'll go with theodolite survey right now. So what is theodolite? So theodolite is used to measure horizontal angle, horizontal and vertical angles directly. Horizontal, we can measure horizontal and vertical angles from this, and indirectly we can measure distances and elevations of objects, right? So there are two types of theodolites. Transit Werner, transit vernier, non-transit vernier. Okay. Next, what is transiting or plunging or reversing? What is transiting or plunging or reversing? It is nothing but the process of rotating the telescope in vertical plane about horizontal axis. Okay. This process of rotating the telescope in a vertical plane about horizontal axis. Okay, that is called transiting of the theodolite or reversing of theodolite. So next, uh, these are the few terms you need to know while theodoliting traversing. Face left observation, face right observation, swinging of telescope, and double sighting or double centering. What is face left observation? Face left observation. When the vertical circle is to the left side of the observer, then the observations made are called face left observations. Okay, so vertical circle is on left side. Is on left side of an observer, then it is called face left. So it is then the telescope is in normal position and the bubble is up. Telescope is in normal position and bubble is up. Okay. Next, what is face right? Face right observations. When the vertical circle is to the right side of the observer, then the observations made are called face right observations. Okay. Vertical circle is on right side of observer. Then the observations made are called face right observations. Okay. By transiting, face left can be made to the face right and vice versa. I already told you. It is nothing but rotating your telescope. By transiting, the face left can be made to the face right and vice versa. Next point is swinging of telescope. What is swinging of telescope? It is nothing but the rotation of telescope in horizontal plane. Rotation of telescope in horizontal plane. Okay. If telescope is rotated clockwise, it is called right swing. If telescope is rotated clockwise, rotated in clockwise direction, then it is called right swing. If telescope is rotated in the clockwise direction, then it is called right swing. If telescope is rotated anti-clockwise, is rotated in the anti-clockwise direction, then it is called left swing. Okay, so what combination is the best combination? We can take like FL, face left, and RS, right swing, face right, and RS. You can't take it like face left and LS, face right and LS. What is the best combination? This is the best combination. Okay. FLRS is the best combination. So next part is double sighting or double centering. What is double sighting or double centering? It is the process of measuring the angle twice. Once the telescope is in normal condition, once in inverted condition. We'll take the readings once in normal condition and in inverted condition. So then that is called double sighting or double centering. Okay. Next, main parts of theodolite. What are the main parts of theodolite? Telescope, leveling head, lower and upper plates. These are also called as vernier plates. These are also called as vernier plates. Plate levels, altitude bulb, vertical circle, tripod, and A strands and T strands. A strands, T strands. These are the major parts of the theodolite. So, what is what are the working operations of the theodolite? Generally, working operation. Both clamp screws are tightened. No movement of telescope. First working operation. Wait, I will write it here. Both clamps, clamp screws, both clamp screws are tightened. No movement of telescope. No telescope movement. Next, releasing lower clamp screw, tightening the upper clamp screw. Okay, then the object can be bisected without the change in the vernier readings. Oops. Releasing upper clamp, tightening lower clamp. So with this, the object can be bisected without change in the vernier scale. Without change in the vernier readings. Next, the third case is releasing the upper cram screw and tightening the lower cram screw so that the object can be bisected with the changes of vernier readings. Releasing upper cram and tightening lower cram screw, object can be bisected without vernier readings. Okay. So next. So I need to remember you one note, one important thing. What is size of theodolite? It is a popular question, popular unmarked question. What is size of theodolite? It is nothing but the diameter of main horizontal graduated scale. Diameter of main horizontal graduated scale. Okay. It is generally 80 mm to 120 mm. This is a popular question. So size of theodolite. Size of theodolite is nothing but the diameter of main horizontal graduated scale. Generally it is 80 mm to 120 mm. Okay. So here comes the fundamental lines and their relations. Fundamental, what are the lines? Nomenclature of the lines present in the theodolite and their relations. So fundamental lines and the relations, what are the lines? Horizontal or triunion axis. Horizontal axis or triunion axis. Horizontal axis or triunion axis. Vertical axis and the line of collimination or line of sight. Okay, line of collimination or line of sight. Axis of plate levels. Axis of altitude bubble. Okay, so what are the fundamental relations? The axis of the plate level must always perpendicular to the vertical axis. Axis of the plate level must always perpendicular to the vertical axis. And next, the horizontal axis must always perpendicular to the vertical axis. And the line of collimation is always perpendicular to the horizontal axis. You need to remember, line of collimation must always perpendicular to the horizontal axis. Axis of altitude bubble must be parallel to line of collimation. Then only we can say that the instrument is in perfect. If this is the case, then the instrument is perfectly horizontal, and the vertical circle reads 0. The vertical reads 0. Okay. So temporary adjustments. What are the temporary adjustments of theodolite and permanent adjustments of theodolite? The temporary adjustments are setting of theodolite, centering of theodolite, leveling of theodolite, and elimination of parallax. Okay. Setting of theodolite, centering of theodolite, leveling, elimination of parallax. So what are the permanent adjustments of theodolite? So permanent adjustments are: one, plate level test; 2. Cross-hair ring test. 3. Azimuth test. 4. Spire test. 5. Vertical arc test. Vertical arc test. Okay. What is this plate level test? To make the plate bubble central to the axis, central to the run, when the vertical axis of three-out light is truly vertical, then that is called. So what is plate level test? We need to make the plate bubble central to the run. So then my vertical axis of theodolite is truly vertical. Okay. I need to do it. I need to do this adjustment first. Next, crosshair ring test. To make the vertical crosshair lie in the plane perpendicular to the horizontal axis. Vertical crosshair lie in plane perpendicular to horizontal axis. Azimuth test. So to make line of sight perpendicular to horizontal axis. Spire test. To make horizontal axis perpendicular to vertical axis. Horizontal axis perpendicular to vertical axis. Okay, now next, vertical arc test. To make the vertical circle indicate 0 when the loss of sight is where the line of sight is perpendicular to the vertical axis. I already told you vertical circle will indicate 0 when line of sight is perpendicular to vertical axis. Okay, fine. Let's look into a problem. A theodolite is placed at A and 3 meters long vertical staff and it is held at B. The depression angle made at a reading of 2.5 meters marking on the staff is 6 degrees 10 minutes. The horizontal distance between A and B is 2200 meters. Height of instrument at A is 1.2. Reduced level at A is 880.88 meters. Using the combined correction, determine the RL of point in meters. So they are asking us to calculate the RL. So first we will draw the diagram, traversing diagram. So it is given 2 points A and B. Okay. Theodolite is placed on a long staff of 3 meters. And it is given the angle made at 2.5 marking is 6 degrees 10 minutes. So this is 2.5 meters. This is B dash and this is B double dash. It is given the height of instrument at A is 1.2 meters and the reduced level here is 880.88 meters. So they are asking us to calculate the reduced level at B, right? Correct staff reading on B. What is the correct staff reading on B? The 2.5 minus error due to refraction, right? Correct staff reading at B. At B is equal to 2.5 minus 0.06735 into 2.2 square, right? So what is the value? 2.174 meters. Next, RL of B is equal to, so reduced level at A minus the distance into, reduced level at A minus the distance into tan alpha, right? Yes. Reduced level at A, what is the level? It is given at A plus height of the instrument 1.2 minus the distance between A and B, it is given 2200 meters into tan alpha, it is given 6 degrees 10 seconds. So what is the reduced level at B? And we need to eliminate, subtract the error also, right? So then what is the corrected level? RL is 642.204 meters. Okay. So this is the RL of B in meters. RL at B in meters. What do we did? We first calculated the correct staff reading on B, and then we calculated the RL at B. So next we'll go for theodolitic traversing. So theodolitic traversing is done with done by few methods. So first method is loose needle method, fast needle method, method of included angles, method of deflected angles. Okay, got it. So these are the methods used for theodolitic traversing. So what are these methods? What do we do in loose needle traversing? The bearings of line will be measured with theodolite with respect to the compass fitted. Okay, that is called loose needle method. Loose needle method. Bearings of lines will be measured with theodolite with respect to the compass fitted. That is inbuilt. Okay. Next, fast needle method. The north direction will be established separately by prismatic compass and the bearings are measured here. It is more accurate than loose needle method. Okay. Here the north direction is always fixed externally, established separately by prismatic compass. The method of included angles. Method of included angles. It is not also called as back bearing method. Okay. So this is used for Galley's traverse table. Method of deflection angles. It is suitable for open traverse. Okay. So traverse computations. This latitude, how do we calculate latitude? Let it be this hypotenuse 1 and latitude is L is equal to this L cos this, let it be L. latitude is L cos theta, departure is L sin theta. Okay. If L and D of a line are given, then length of line is root of L square plus D square. We know that, right? And the bearing of line theta is equal to tan inverse of D by L. If the latitude and departure of line are equal, then the bearing must be 45 degrees. Okay. Here the bearing can be 45 degrees. Consecutive coordinates or dependent coordinates. These are L and D of succeeding station with respect to preceding line. Okay. Next, these are the coordinates of A and B. If A theta, then B. If the length is L1, then B L1 cos theta. Coordinates is L1 cos theta 1, L1 sin theta 1. If the length is L2, L2 cos theta 2, L2 sin theta 2. These are the coordinates, total coordinates or independent coordinates. These coordinates of stations will be calculated from the assumed origin. Got it? Next, there will be a few times, if you can see, while traversing A to B, B to C, C to D, D to E, A to, sometimes there will be closing errors. Sometimes there will be closing errors, right? In a closed traverse, when we are going for a closed traverse, then sometimes there will be closing errors. Here AA dash is the closing error. In a closed traverse, the algebraic sum of latitudes of all lines must be equal to 0. Algebraic sum of latitudes at all lines must be equal to 0. And same, algebraic sum of, equilibrium. Algebraic sum of departures of all lines must be equal to 0. So these are the conditions in closed traverse. Sigma L is equal to 0, sigma D is equal to 0. Okay. So algebraic sum of latitudes of all lines except AA dash plus latitude at AA dash must be 0. So sigma L plus L dash must be 0. So sigma L is equal to L dash is equal to minus sigma L. Similarly, D dash is equal to minus sigma D. So what is the closing error? Closing error is equal to E is equal to root of sigma L square plus sigma D square. Next, bearing of AA dash theta is equal to tan inverse of sigma D by sigma L. This is the angle of misclosure. Got it? So can we do a problem on this? Problem on closing error? Fine. Here are the data given, line, latitude and departure, and they are asking us to calculate the closing error and the angle of misclosure. So what do we need to do? First, we need to calculate sigma L, right? So what is sigma L? 10, 100 plus 250 minus 600. What is sigma L? Minus 250. Sigma D minus 200 minus 100 plus 500. So what is the value? 200. So what is your L dash? 250, D dash 200. So what is the closing error? Is equal to root of 250 square plus 200 square. What is its value? 320.16. Okay, this is the closing error. And next they are asking the angle of misclosure. Theta is equal to tan inverse of sigma d by sigma L, right? So tan inverse of, what is your sigma d? 200. What is sigma L? 250. So tan inverse of this value is 38.65 degrees. So it can be note, we can also designate this as it is in the first coordinate, right? North 38 degree 65 west. We can also designate it like this. So this comes near this. These are traversing problems. Next, balancing the traverse. So in this there are four methods: Bowditch's method, Bowditch's method, transit rule, graphical method, and axis method. Okay. So what is Bowditch's method? In this method, the linear measurements are directly proportional to root L, and the angular measurements are inversely proportional to root L, where L is the length of traverse. Okay. So linear measurements are directly proportional to root L. Angular measurements are inversely proportional to root L. L is nothing but the length of the line in traverse. So these are the methods used for balancing the traverse. In Bowditch's method, my linear measurement is proportional to root L, and my angular measurement is inversely proportional to my length of the traverse. Okay. And correction of latitude. Here the correction to latitude, CL is equal to sigma L into L by sigma L. Correction due to departure. Correction due to departure. CD is equal to sigma D into L by sigma L. What is sigma L? It is nothing but the perimeter of the traverse. Sigma, what is sigma L? It is nothing but the perimeter of the traverse. Okay. So this is the Bowditch rule. Okay. Next, transit rule. What is transit rule? This is most suitable for theodolite traversing, in which angular measurements are accurate than linear measurements. Most suitable when angular measurements are accurate than the linear measurements. So my CL is equal to sigma L into L by LS. CD is equal to sigma D into D by DS. What is LS? Arithmetic sum of latitudes. LS, sum of latitudes. DS, sum of departures. Okay. So let's suppose I have given L and D as this values. And they are asking me to calculate CL. So how do I do? So first thing is I will calculate sigma L and sigma D. What is sigma L and sigma D? It is 30. If you do this 30 and this is minus 50. What is LS? LS is 70. DS is 130. Right? Then CL is equal to 30 into 10 divided by 70. 4.286. And CD is minus 50 into 40 divided by 130. It's nothing but 15.385 when we calculate it. Okay. So LS is the arithmetic sum of the latitudes. Next method is graphical method. Next method is graphical method. So there is a graphical representation of this all the points C, D, E. Okay. So this is L1, L2, L3, L4, L5. You can see A is hasn't changed, B to B dash, C to C dash. So this is D, D to D dash, C to C dash, B to B dash. This is graphical method, graphical representation. Next is axis method. Next is axis method. It is adopted when angles are measured very accurate and the corrections to be applied only along the lines. Then we considered axis method. Angles measured are accurate and correction to be applied only to lines. Then relative error of closing, relative error of closure, relative error of closure is nothing but closing error by perimeter. So E by P, I can take it as 1 by E by P. Okay. So degree of accuracy of linear measurements is degree of accuracy of linear measurements is nothing but E by P. Okay. So degree of accuracy of angular measurements is equal to tan inverse of E by P. Okay. So these are the traversing things, balancing the traverse, how do we traverse using theodolite and all. Next, omitted measurements. Few measurements are omitted. So how do we calculate those measurements? So let's consider A to B, C, D, E. I know A, B, B, C, C, D, D, E, but I want to calculate AE. How do we do that? So length of EA, as I already told you, length of EA is equal to root of sigma L square plus sigma D square. Okay, got it? So first, if my length and bearing of one side is missing, then how do I calculate? Like this. Next, length of one side and bearing of adjacent side are omitted. This is case 1 and this is. And this is your closing line. If length of one side and bearing of adjacent side are omitted, line, length, bearing. So AB, BC, CD, DE, EA. I got this one, DE I don't know, okay. And bearing also, EA I don't know. Then how do we calculate? So generally what do we do is, we just apply the sine rule in ADE. Apply sine rule in triangle ADE. What is sine rule? You know it, right? Sine alpha by EA. Here in this case, I am taking in the triangle ADE. Sine beta by AD, angle included. Sine gamma by the angle opposite to it, DE. Right? So I want this sine beta value. I want sine beta. So sine alpha into dA by EA. From this, beta is obtained and gamma is nothing but 180 minus of alpha plus beta. Okay. And how do we calculate the length of the side? DE is equal to sine gamma into EA by sine alpha from the sine rule. Got it? So like this, we will calculate the values. Next is trigonometric leveling. Here ends the most parts of traversing. I have gone through all the parts of traversing. Next, let's go for trigonometric leveling. What is trigonometric leveling? It is an indirect leveling in which heights and distances are calculated using vertical angles. Trigonometric leveling. Okay, it's an indirect leveling in which heights and distances can be calculated by measuring vertical angle. So we'll see a few cases in trigonometric leveling before we wind up the session. So case 1, when base of object is accessible, base of object is accessible. So like this. This is Q. This is your backside here, and this is your benchmark, and this is the distance between the 2 points while you traverse. Oh. So this angle is theta. Okay. When the base of the object is accessible, then your V vertical height is equal to D into tan theta, right? So my RL, reduced level of Q, is equal to RL of BM plus BS plus V. Got it? So in case of my base of the object is accessible, then this is the method we use to calculate RL of other point. Next, second case, case 2. If the base is inaccessible, base is inaccessible, so so if my base is inaccessible, then how do I calculate height of that object? Generally, we'll uh, take two stations. In one position, we will look at the top position to different angles. This is alpha 1, and from this tearlet it is alpha 2, from two positions. This is BS and this is BM benchmark. And the distance between these two is B and this is D. Then my V is equal to D tan alpha 1, that is equal to D means D plus B, right? So here the total length is B plus B into tan alpha 2. So my D is equal to B tan alpha 2 by tan alpha 1 minus tan alpha 2. Okay, if my base of object is invisible, then D. Next, RL of Q is equal to RL of BM plus BS plus V. Okay, so this is the case if my instruments are both at same level. Instruments at same level. In some cases, we can't keep the instrument at same level. There may be more undulations of the land. Then okay. If my instruments are at different levels, okay. This is V1 and this is V2 of the object. And you can see this is your S1. The difference between these two is S. This is your S2 and this is your S1. Okay, if base is inaccessible and the instruments are both at different points and the distance between these two are B and D, then S2 minus S1 is equal to, yes, you know it, that is equal to V1 minus V2. So what is V1? D into tan alpha 1. What is V2? D plus B into tan alpha 2. So D is equal to S plus B tan alpha 2 divided by tan alpha 1 minus tan alpha 2. Got it? And my RL of Q is nothing but RL of BM plus S1 plus V1 or RL of BM plus S2 plus V2. Got it? This is the case if my S2 is greater than, this is the case S2 is greater than S1. If my S1 is greater than S2, then what is the case? Then D is equal to S minus B into tan alpha 2 by tan alpha 2 minus tan alpha 1. Got it? This is the formula. So like this, we'll traverse in trigonometric leveling. Okay, these are the formulas you need to remember. So these are the main cases of trigonometric leveling. Next, we'll just introduce tachyometric survey. What is tachyometer first? Tachyometer. Tachyometer is a theodolite in which special diaphragm with top, central and bottom cross lines between eyepieces and objects of the telescope. It is nothing but a theodolite which has a special diaphragm with top, central and bottom cross lines between eyepieces and objects of the telescope. The accuracy of tachyometer is 1 in 1000. So what are the systems of tachyometric survey? What are the systems of tachyometric surveying? One, stadia hair system. So in this, there are two types of system: fixed stadia hair, mobile stadia hair. Next, tangential method and by special instruments. Got it? So what is stadia hair method? Let us consider for fixed first. So let it be beta by 2, this angle A2, B2, A1, B1, A, B. So this is C2, C1, C. Okay. So from the ratio of perpendiculars, the ratio of perpendicular to the base is constant. Ratio of perpendicular to the base is constant. Then we know OC by AB is equal to OC1 by A1B1, that is equal to OC2 by A2B2 is equal to constant. Yes, we know that rule, right, from geometry. Then tan beta by 2 is equal to A2C2 by OC2. So what is A2C2? Half of A2B2 divided by K into A2B2. So what is the constant? It is half cot beta by 2. If my beta is 34 degrees and 22 minutes, then K is equal to 100. Okay. If my beta is like that, then K, the constant value is 100. Next, when my line of horizontal is, when my line of sight is horizontal, then my horizontal distance between two, when we are using the Stakia method, is D is equal to Ks plus C. Okay, I'll show you. So this is O and this is F2, focal length of first and second lenses, F1, and this is I and this is S. Okay. Then M is the center of instrument. O is the optical center of object. O is the optical center of objective and eyepiece. S is the staff intercept. I is the stadia intercept. D is the distance between optical. It's not D. Alpha. Alpha is the distance between optical center and center of instrument. And capital D is the horizontal distance between the object and instrument. F1 and F2 are the focal lengths of eyepiece. We all know F1 by F2 is equal to S by I. 1 by from optical lens formula 1 by F is equal to 1 by F1 plus 1 by F2. This is from similar triangles formula. So multiplying with FF1, then we will get F1 is equal to F plus F of F1 by F2. That is equal to F plus F of S by I. The horizontal distance D is equal to F1 plus D. So my F1 is F plus F into S by I plus distance D. So we are considering it as constant Ks plus C. K is nothing but F by I. This is called multiplicative constant. Multiplicative constant. And C is nothing but F plus D. Additive constant. Additive constant. You need to remember these two terms. Okay. K multiplicative constant. It is nothing but F by I. C is equal to F by T. It is additive constant. Okay. So in this two types, constant hair method and mobile hair method, those are the things we'll discuss in the next class. Let's call it as a day. Thank you for your patient listening.